right, today in Algebra 2, we're going to finish up section 5.2. So we're going to skip to the notes in the add and subtract radical expressions part. Okay, like radicals will have the same index and radicand. So like radicals are those that have the same index and radicand. Only like radicals can be combined with addition and subtraction. Okay, so we just want to add, subtract. We want to simplify these. So I have the square root of 20 minus the cube root of 16 plus the cube root of 250 minus the square root of 5. So my index, I have a square root of 20 and a square root of 5. I cannot combine them though, even though they have the same index right now because they don't have the same radicand. I have a 20 and I have a 5. So I can go ahead and put them together. So I'm looking at the square root of 20 minus the square root of 5. And then I've got minus 3 square roots of the cube root of 16 plus the cube root of 250. So now at least I have the ones that have the like indexes together. So now I'm going to see, can I make them have the same radicands so that I can combine them. So I'm going to do factor tree on 20. So it's 5 and 4, 4, 2 and 2. So this is really 2 square roots of 5 minus the square root of 5. Now those are alike, I can actually combine those. So now we're going to come over here and do the same thing with the cube root of 16 and the cube root of 250. So 16 I can break down to, let's see, 4 and 4, or 2 and 2, 2 and 2. This time I need 3 things to be alike. So this is really minus 2 cube roots of 2. 250, it's 10 and 25, 25, 5 and 5, 10, 2 and 5. I've got 3 5s, so this would be plus the cube root of, plus 5 cube root of 2 got left behind. So now I can do the like parts. So 2 square roots of 5 minus the square root of 5. They have the same index, they have the same radicand, so I leave that alone and I simply combine the numbers out in front. So really I have 2 minus 1. So 2 minus 1 is just 1, so I have 1 square roots of 5, or just the square root of 5. The cube root of 2's, okay, so I have a negative 2 plus 5, so that's going to give me plus 3 cubed root of 2. So there's my answer after I have simplified all of that. All right. Now let's look at another one. So number 2, the cube root of 2000. So, and the cube root of 128, square root of 2. I see the square root of 2. I know that I'm going to have the square root of 2 just in my answer because it's the only one that has an index of 2. So let's do factor tree on the cube root of 2000. So 2000 came from 120. 100, 10 and 10, 20, 10 and 2. I've got 3 10s right there. So I've got a 10 cube root of 2. Now let's do factor tree on 128. Let's see, 128 came from 2 and 64. 64 is 8 and 8. 8 is 2 and 4. 8, 2 and 4. 4, 2 and 2. 2 and 2. So I've got 3 2's there, 3 2's there, and then 1 2 left behind. So I've got minus 2 times 2, 4 cubed root of 2, and then plus the square root of 2. So now I have cube roots of 2's. I have a 10 minus 4, so that's going to be a 6. So I've got 6 cubed root of 2 plus the square root of 2. Usually we will write them in with the smallest index first. So I'm just going to rearrange that and make that say the square root of 2 plus 6 cube roots of 2. There we go. Number 3, I see that they're all square roots. So right now I'm just going to do factor tree to get my radicand, see what I've got in here. So 20, 10 and 2, 10, 5 and 2. So this is really 2 square roots of 5. 600, so I can do that 106. 100 is 10 and 10, so I can stop right there with the 10s. So minus 10 square roots of 6. 125, 5 and 25, 25, 5 and 5. So I've got a pair of 5s. So minus 5 square roots of 5. So I only came up with the first one and the last one that had the same radicand. So I have a 2 minus 5. That gets me a negative 3 square roots of 5 minus 10 square roots of 6. I cannot do anything else with that because I have a radicand of 5 and a radicand of 6. All right, let's look at some word problems. So this first one, it says the design shows the boards needed for bracing the back of some set scenery. It wants to know, will 75 feet of wood be enough for all the bracing? And so they're showing me the bracing that they have here. All the way across here is 7 feet. All the way across here is 4 feet. Okay, so if I look at this diagonal and this diagonal. So we're looking at diagonal of the small square, diagonal of the large square. So I'm just going to call A the length of the diagonal. This is the length of the diagonal of the small square. And B is going to be the length of my diagonal of the large square. I need to find the area because I want to know 75 feet enough for all the bracing. So I need to find out, okay, here we have wood, here we have wood, here we have wood, here we have wood. And then, so basically all of this that's in the orange. I need to find out how much is all of this, right? So I need to know what's the length of these, okay? They tell me that this one is 4, so I know that this is 4, this is 4, and this is 4. So right now I've got 3 edges at 4 feet, right, in my small square. I don't have to count this 4 feet because this is also part of this, so this is going to be 7, 7, 7, and 7. So I've got 7 edges, or sorry, not 7 edges, wow. I've got 4 edges at 7 feet. Okay. So here I've got 12 feet. Right. 3 times 4, I've got 12 feet. Here, 7 times 4, I've got 28 feet so far. So right now, 28 plus 12, I've got 40 feet that we need of wood just for the outside edges of the bracing. So now we need to get these diagonal pieces right here. And so that's what I'm working on right now, where I said I'm going to call A and B, right? So I'm going to call A this one and B this one. And notice, what do I have in here? I have triangles, right? So I'm going to pull out that small triangle. You know, this is 4, this is 4. This is my A, right? Notice that these are squares, so I know I've got right triangles. So I'm just going to do Pythagorean theorem, right? So I get A squared equals 4 squared plus 4 squared. So A squared equals 16 plus 16. A squared equals 32. Take the square root of both sides. Factor tree, so this is 8 and 4, 2 and 4. I have a pair of 4s. So here I get that A is equal to 4 square roots of 2. I have 2 of those, though, over here in this small triangle, right? So I have 2 diagonals at 4 square roots of 2. So that gets me 8 square roots of 2 feet right there, right? So now we're going to do the same thing with the big square. So my big square, this was B. These were 7 and 7. So again, Pythagorean theorem gets me B squared equals 7 squared plus 7 squared. B squared equals 49 plus 49. B squared equals 98. Take the square root. Factor tree of 98, well, that came from 2 and 49, 7 and 7. So then I have B is 7 square roots of 2. So now I've got two diagonals, 7 square roots of 2. So that's 14 square roots of 2. So right now, the total wood that we need is 40 feet plus 8 square roots of 2 feet plus 14 square roots of 2 feet. Right? I can combine these because they have the same radical, or so, same radicand and index. So 8 plus 14 gets me 22 square roots of 2. So this is how much wood I need. 40 plus 22 square roots of 2 feet. Oh no, is that 75? Is that bigger or smaller than 75? So this is where we would pull out a calculator and find out what is the decimal version of that. So 22 times the square root of 2 is 31.11. We're just going to approximate, so plus 31.11. So this is approximately 71.1 feet of wood that we would need. So that's smaller than 75. So yes, 75 feet of wood will be enough. So this problem was pulling all kinds of previous information from Algebra 1, geometry, knowing about a square, our diagonals, Pythagorean theorem, right triangles, and then adding radicals. All right, so flip over to the back. Yesterday we looked at the multiplying binomial radical expressions, so we can skip down to rationalize a binomial denominator. We did some rationalizing denominators in geometry, and you probably did that in Algebra 1 as well. Okay, so it tells you to rationalize a denominator that has a binomial denominator. You simply multiply by the conjugate. Okay, so just remember that we cannot have a radical in the denominator. Okay, so to rationalize the denominator means to get rid of the radical in the denominator. We already know what the conjugate is. Conjugate just means you change the sign of the addition or subtraction. So number 1, it says find the reduced radical form of each. 1 over 2 plus the square root of 5. I need to get rid of that 2 plus the square root of 5, so the conjugate is 2 minus the square root of 5. So I'm going to multiply top and bottom by 2 minus the square root of 5. So on top, I have 2 minus the square root of 5, right? Over my conjugates, remember we have a conjugate shortcut. That conjugate shortcut tells us you take the very first term and you square it, so 2 squared is 4. Always minus the last term squared. The square root of 5 squared is just 5. So now I have 2 minus the square root of 5 on the top, over 4 minus 5, negative 1. I can just change the sign of everything on top, so I get negative 2 plus the square root of 5. No more denominator. All right, let's look at number 2. Negative 4x, all of that divided by 1 minus the square root of x. So the conjugate of the denominator is 1 plus the square root of x. 1 plus the square root of x. So on top, I need to distribute. So negative 4x times times 1 is negative 4x. Negative 4x times the square root of x is just minus 4x square roots of x. All over my conjugate shortcut, first term 1 squared is 1, always minus, the square root of x squared is just x. Right? Squaring a radical just takes the radical away. Now the top I could actually factor, right, that negative 4x back out if I wanted to, and make this say negative 4x times 1 plus the square root of x, which is what we started out with up there, over 1 minus x. Okay? Since it says reduced radical form, we're going to simplify as much as we can. And finally, the last one, 5 minus the square root of 2 over 2 minus the square root of 3. I multiply only by the conjugate of the denominator, so 2 plus the square root of 3, 2 plus the square root of 3. This time, the top, I have a binomial times a binomial. I'm going to have to FOIL. So I would do my 5, distribute my 5, so 5 times 2 is 10. 5 times the square root of 3 is just plus 5 square roots of 3. Now I'm going to distribute the negative square roots of 2. So I would have minus 2 square roots of 2 minus the square root of 2 times 3 is the square root of 6. All over conjugate shortcut. So the very first term, 2 squared, is 4, minus the last term, the square root of 3 squared, just becomes 3. On top, I look at, can I combine anything? I have a square root of 3, a square root of 2, a square root of 6. There's nothing that I can combine. Okay? So on the top, I have 10 plus 5 square roots of 3 minus 2 square roots of 2 minus the square root of 6. All over 4 minus 3 is just 1. So there's our answer. All right, so that finishes up section 5.2 for us. Homework today, looking at a long homework assignment, okay? But they should not take us that long, right? And it's really not that long. I say it's long, but the same worksheet from yesterday, 5.2. We're going to do numbers 37 through 40, numbers 45 through 48, 49 through 52, and 55. So some of these, they're at the end, the 49 through 52 and 55 are some word problems that I want us to look at. All right, that wraps up section 5.2 for us.